Hey everyone, Math 105, this is Lesson 8, Solving Literal Equations. Now literal equations are those with more than one variable in them. With a regular equation, our solution is going to look like variable equals constant. But with literal equations, this changes to variable equals an expression, and there will be some variables over on this side. One thing you need to keep in mind is the variable on the left that's by itself, this is the only instance of this variable that we'll see in the equation. There will be no instances of the left variable in the expression on the right. Here's an example of a literal equations. We have two variables, x and y. And we're going to solve this for y. So we need to get y all by itself. Well, first thing we need to do is get rid of this other term on this side of the equation. So we'll subtract 3x from both sides. All that's left on the left is 4y, and on the right we get 12 minus 3x. Now in solving a lot of equations, we might have a number over here, so when we subtract, we'd be able to combine these two into one number. So that helps simplify the process. Literal equations are more complex because we have to keep that variable and then keep the expression. Next step, to get y by itself, divide both sides by 4. And now we've got this fraction, and fractions like this can be split up into two different fractions and then simplified. So both of these terms are being divided by 4. So we're going to have one fraction here and one fraction here. So this splits up into 12 over 4 minus 3x over 4. And then within these fractions, we can look for opportunities to simplify. So we got 12 divided by 4 is 3. So our final answer is going to be y equals 3 minus 3x over 4. Now we've solved for y. Y is by itself. Your turn, number 1. And again, we're solving for y. Now, a shortcut we can use when moving terms from one side to the other. We're subtracting 3x from both sides. That gets rid of us on this side. So what actually happens is the 5x moves to the other side and it changes the sign. It goes from positive to negative. So there's a little shortcut we can use here. So 2y equals 10 minus 5x. And now we can go ahead and divide by 2. So that's 10 minus 5x over 2. And we'll split up that fraction so we can simplify. And then the first fraction turns into 5. So you go y equals 5 minus 5x over 2. Now things get a little more complex when we've got a negative coefficient on the variable we're trying to solve for. All right, I'm still going to take the 5x and move it to this side, but make sure you keep that negative with the 6y. Don't lose that negative. The sign is on, the sign precedes the term that it's with, so the sign has to stay with 6y. So moving the 5x to this side gives us negative 6y equals 24 minus 5x. Now you've got to divide by a negative number. So divide by negative 6. And now this fraction, we're going to break it up again. But now we're dividing by a negative number, so we have to keep very close track of the signs. Here we've got positive 24 over negative 6 minus 5x over negative 6. All right, so we actually have two negatives over here. So that's going to turn this part positive. 24 divided by negative 6, positive by negative is a negative. So we get y equals negative 4 plus, whoops, didn't mean to put that x there, plus 5x over 6. So basically what we have here is a negative times a negative turns this positive. And you can also write this as y equals 5x over 6 minus 4. Your turn, number 2. So we're solving for y, so we're going to move that x over here. The negative stays with the 3y. Now we can divide both sides by negative 3. Now to get this big fraction, we're going to split this thing up. So that's 21 over negative 3 minus x over negative 3. Then this turns into negative 7. Here the negatives cancel, we get plus x over 3. Or you can write it as y equals x over 3 minus 7. Either one of those is fine. Now the next part works best if you have a partner. But if not, you can just do both sides on your own. So how this works is we're going to solve the same problem in 2 different ways. All right, so the first way, what we're going to do is just immediately substitute the values right into the expression and then solve as we normally do. And in the second part, partner 2, we'll solve the literal equation first. Once you have the variable isolated, then plug in the numbers and evaluate. So the first one, we're given that d is 56 and r is 8. So we just go ahead and plug that right in. 8 for r, 56 for d. Divided by 8 on both sides, and t equals 7. Now over here, what we can do is we're going to solve for t. So we're going to divide both sides by r. The r's cancel here. We just have d over r. And then plug in the values. 56 and 8 for r. And that gives us 7. So we get the same answer either way. Your turn, number 4. X plus a equals b. And we're given that A is 12 and B is 7. So on the left, we're going to plug those in right away. And on the right, we're going to solve this for x. So I'm going to subtract a from both sides. X equals b minus a. All right, now over here, now we got the numbers in. Subtract 12 from both sides, and we get x equals -5. All right, now that we have this solved for x over here, now we can plug the numbers, and we get 5 minus, or, oops, let's say 7. 7 minus 12. X equals -5, so same answer. Your turn 5. D equals C times A minus B. And we're given that A is 11. So we'll plug in an 11 here. B is 8. And D is 12. So we can evaluate here. 11 minus 8 is 3. So that gives us 3C here. Divide by 3 on both sides, and C equals 4. Now here, we're going to go ahead and solve for C first. We have this multiplied by a binomial. It's okay to divide both sides by a binomial, no problem. We can divide this side of the equation by A minus B, and divide this side by A minus B. The A minus B's cancel on this side. Those all go away, leaving just C. So we end up with C equals D over A minus B. Now we can plug in values. Now we got 12 for D, 11 for A, and 8 for B. Which is 12 over 3, or 4. Your turn, number 6. Four x minus C equals D. We've got C is 15, and D is 9. So 4x minus 15 equals 9. Add 15 both sides, so we get 24 on the right, divided by 4, and x equals 6. Now over here, we are going to solve for x. So I'm going to take the C term and move it over here. It turns from negative to positive. So 4x equals C plus D, and then divide by 4, and we get x by itself. X equals C plus D over 4. So C is 15, and D is 9. And we get a 6 there as well. That brings us to your turn, number 7. So now we got c minus s over t. R is 2. I'll plug in 2 here. And solving for c. S is 18. And t is 6. Okay. So if we want to find the value of c, first thing we need to do is get rid of this denominator in the fraction. So if we multiply both sides by 6, that will go away. 6's cancel, so we got 12 equals c minus 18. Add 18 to both sides, and c is 30. All right, now we're going to do similar operations over here. Keep in mind the order we did things in. First thing we do is multiply both sides by the denominator. We're going to do the same thing here. Denominator is t, so we're multiplying by t instead of 6. Other than that, nothing else changes. All right, now the t's cancel, so that leaves us, I'm going to write it as RT equals c minus s. Now we're still looking to get c by itself. Last thing left to do is add s to both sides. So we get RT plus s. And that's the expression we can plug right into now. All right, R was 2. I'm just going to switch this around. And then plug in. R is 2. T is 6. And S is 18. So that's 12 plus 18, or 30. So we can start to see the advantages of doing this if we have a whole bunch of calculations to do. So if we have to run through a bunch of these, that means every time we run numbers through it, we're going to have to do all these steps every time. But if we just solve for the equation first, solve the literal equation, and then if we plug in, it's an easy calculation to make. So that ends up being a big time saver if you have a lot of these to do. Next up, your turn number 8. So we have a version of a famous equation from physics, the V equals IR equation, in a little different form. And we are going to solve this for I. So I is in the denominator of the fraction. So there is a very quick trick we can use if we want to solve for the denominator fraction where it's set equal to either a single number or a single variable. And we can do the swap trick. So all you have to do is swap position of R and I, and we're done. Actually, that would be over on this side. So I goes where R is, and R goes where I am. And now our equation is solved. So why does this work? It's 2 steps in one. First, you multiply both sides of the equation by I to get rid of this denominator. So that's gone. So IR equals V. Now we're solving for I, so that means we're going to divide by R. Get rid of the R's here, and I equals V over R, just like we have here. So 2 steps can be done just by swapping R and I. All right, now that we have a solve for I, now we can plug in 36 for V and 4 for R. So I equals 9. Now in this one, we're plugging in first. So we got 4 equals 36 over I. And doesn't matter if there's numbers in there or variables, we can still do the swap trick. So flip those. I equals 36 over 4, which is 9. So not a whole lot of time saved on that one. But we did learn a very important trick. So make sure use that if we're ever solving for the denominator of the variable and it's equal to a single number or variable. Number 9. L equals A times 1 plus CT. So we got L is 25, A is 5, and T is 2. So we got 2T. Now we're going to solve this thing for T. The first thing we need to do is get rid of this multiplier on the outside of the parentheses. Remember, reverse order of operations. We don't start within the parentheses, we start outside of them. So divide both sides by 5. The 5's here cancel, and we get 5 equals 1 plus 2t. All right, now we can get rid of the 1. So just subtract 1 from each side, and we get 4 equals 2t. Divided by 2 on each side, and t equals 2. And now this one, we're just going to solve this equation for t. So just like over here, we started dividing by 5, so here we'll start dividing by a. Divide both sides by a. That gives us L over A equals 1 plus CT. All right, what do we do next over here? We subtracted the 1, so let's subtract the 1 over here. So we got L over A minus 1 equals CT. All right, last thing we need to do is solve for T, so I'm going to divide everything by C. Now, this looks a little strange. What we're actually doing here is we have two terms, so we're dividing this term by C and we're dividing this term by C. One second here. I believe I solved for the wrong variable. Yep, I should have plugged in 2 for T instead of C here. So that should be C, C, C. Yeah, I knew something was wrong. Okay, so we're not dividing by C, we're dividing by T. All right, now on the right, T's cancel. Now I've got a fraction divided by T. What happens is that T just ends up in the denominator. So that's L over AT. And then 1 divided by T is just 1 divided by T. And so there's the expression we can use then, and now we can plug right into it. So L was 25. And A is 5. And T is 2. So we got 25 over 5 times 2 minus 1 over, and T is 2 again. So what do we get on the left? We get 25 over 10. And to make the subtraction easy, I'm just going to write this fraction as over 10. So 1/2 is the same as 5 over 10. So that gives us 20 over 10, which is 2. Your turn, number 10. So our formula is S equals A plus N minus 1 times D. And we're going to solve this for N. N is inside the parentheses. So we're going to have to get rid of all the stuff on the outside before we can get to the N. And then on the left, what we're doing is plugging in first. So we're going to plug in 26 here. And A is 2. And D is 4. So we got N minus 1 times 4. So first thing we can do here is get rid of the 2. Subtract 2 from both sides. And then divide by 4. So 6 is N minus 1, add 1 to both sides. And N is 7. Alright, let's solve this thing for N. So we're going to follow the same procedure here. First thing we do is subtract the 2. So I'm going to subtract the A. Subtract A from both sides. So that gives us S minus A on the left and N minus 1 times D on the right. Now we can divide by this D. So we get S minus A over D equals N minus 1. And last thing we need to do is add 1 to both sides. So that gives us S minus A over D plus 1 equals N. Now we can plug it into this formula. So that gives us N equals, S is 26, A is 2, and D is 4. So 26 minus 2, that's 24. So 24 over 4 plus 1, or 6 plus 1, or 7. Your turn, number 11. Working with the equation W equals B plus A times X minus BT. We are given W equals 1, B equals negative 5, A is 3, X is 10, and T is 4. So the only variable left is V, so we got to figure out what that is. So let's start over here by getting rid of the negative 5. Add plus 5 to each side. So 6 equals 3 times 10 minus 4V. Now we'll divide by 3. So your 2 equals 10 minus 4V. Now let's subtract 10 from each side. So that's the negative 8 on the left. And over here, remember the negative sign stays with the term that follows it. So it's negative 4V. And finally, we'll divide by negative 4 to get V equals 2. Alright, so let's follow this kind of a procedure then and solve this thing for V. So first thing we did was get rid of the B, so let's do that. I'm going to subtract b from both sides. Alright, so move the b to the left, make it negative. Now we can divide by a just like we did over here. We divided by the 3, now we'll divide by the a. That gives us w minus b over a equals x minus bt. Next thing we did here was subtract the 10, so we're going to subtract the x. And the negative stays on vt. Now to solve for v, the last thing we have to do is divide by negative t. So what happens over here? Well, this fraction turns negative, so I'm just going to put the negative up front. Numerator stays the same, and then the t ends up in the denominator along with the a. So that's a t. And then for the second fraction, we've got negative x divided by negative t, so the negatives cancel. So that ends up being plus x over t. And now we can go ahead and plug in. So w minus b, so w is 1, and b is negative 5, so we're subtracting negative 5. And on the bottom, a times t, that's 3 times 4. And then x over t, that's 10 over 4. So the numerator of this becomes, say, 1 minus negative 5 is the same as 1 plus 5, so that is 6. And 12 on the bottom, plus 10 fourths. Alright, so this is basically 1/2. If we express it over 4, that'd be 2 over 4. But there's lots of different ways we can combine these fractions. And let's see. Oops, I did forget a sign. I knew I was going to do that. So that negative out front of this fraction, so that has to be negative. That's what I was missing. Okay, so that gives us over here, that fraction is negative. Alright, so that is negative 1/2 plus 5/2. I took 10 fourths and reduced it to 5/2. And combine it, and that is 4 over 2, which is 2. Your turn number 12, temperature. So the equation to convert between Fahrenheit and Celsius is F equals 9/5 C plus 32. So if you can plug in a Celsius temperature here, get a Fahrenheit out. But we want to do the reverse. We're going to plug in a Fahrenheit temperature and get Celsius out. So let's solve this thing for C. All right, I'm going to subtract 32 from both sides. So that's F minus 32 equals 9/5 C. Now to get rid of that a fractional coefficient for the variable, we're going to multiply by its reciprocal. Flip that fraction over. So multiply both sides in this equation by 5/9. Alright, 5's cancel, 9's cancel, leaving just C. So we get C equals 5F over 9. Minus, then we'll do 32 times 5/9. That is 169. And there's the equation we can use to go from Fahrenheit to Celsius. Now we've got Fahrenheit of 77, so I'm going to plug in 77 here. So 5 times 77 gives us a 385. So that's 385 ninths minus 160 ninths. Subtracting, we get 225 ninths, which is 25. So 77 Fahrenheit corresponds with 25 degrees Celsius. That brings us to your turn number 13, simple interest. The equation is definitely not simple. So you got the simple interest equation. A is the final amount of money in the account. P is the principal, that's the amount invested initially. R is the rate as a decimal, and T is the time in years. We're going to solve this equation for T, and then we'll figure out if 10,000 is invested at 6% interest, find the amount of time it takes for the account value to go to 12,000. So since we're finding time, that's what we're solving for T. So we'll start by dividing both sides by P. Always get rid of that thing outside the parentheses first. So A over P equals 1 plus RT. Now we need to get rid of the 1. Remember, reverse order of operations. So subtract 1 from each side. That's A over P minus 1 equals RT. And then we'll divide both sides by R. Again, fraction divided by something, that goes in the denominator. So A over PR minus 1 over R equals T. And that's the equation we can use. Now we can plug in the known values. We got 12,000 is our goal. We want 12,000 in the account. Principal is 10,000. And the rate is 6%. Convert that to a decimal, 0.06. By multiplying this out, get 600 on the bottom, and 1 divided by 0.06 is 16.7. If we divided this out, we get 20. So that's 20 minus 16.7, and T equals 3.3 years. So at 6% interest, 10,000 will grow to be 12,000 in 3.3 years. Your turn number 14, area of a trapezoid. So H is the height of the trapezoid, B1 and B2 are the length of the bases. Trapezoid looking like something like this. So height, base, and base. And knowing those three, we can calculate the area. However, we know everything except B2. So that's what we're solving for. So we got a fraction here. I want to get rid of that, so I'm going to multiply by its reciprocal. If we take 1 over 2 and flip it over, we get 2 over 1, which is just 2. So I'm going to multiply both sides of the equation by 2, and the 2 and the 1/2 cancel. So we got 2a on the left, and h times b1 plus b2 on the right. All right, now divide by the thing outside the parentheses, so divide by h, and we get 2a over h equals b1 plus b2. And we're solving for b2, so the last thing we need to do is subtract b1 on both sides. So we get 2a over h equals, or minus b1 equals b2. And now we can plug in the known values and figure out the length of base 2. The area is 40 square meters. So we got 2 times 40 up top. The height is 8. 8 goes on the bottom. And base 1 is 4 meters, so minus 4. 2 times 40 is 80, so we got 80 over 8 minus 4. And we get 6, and let's see, in meters. So height of the second base is 6 meters. Your turn, number 15, the ideal gas law. This is something widely studied in chemistry classes. Ideal gas law. It relates the pressure of a gas and its volume. N is the number of moles, which is just a count of the number of particles. R is a constant, and T is the temperature in Kelvin. So we are going to find out the temperature of a gas when knowing everything else. So we're going to solve this for T. All right, so I've got 2 variables along there with T. They're all multiplied. So we'll divide both sides by NR. The N's cancel, the R's cancel. So that gives us T equals PV over NR. Pressure is given as 2.7 atmospheres. The volume, 1.2 liter tank. The number of moles, 0.18 moles of the gas. And R is a constant, 0.082. So multiplying this out, we get 3.24 on top and 0.1476 on the bottom. Finally divide to get 219.5 degrees Kelvin. Oh, that may seem like a very high temperature, but that's actually very cold because it's in degrees Kelvin, which is measured from absolute 0. Your turn, number 16, universal gravitation. So this equation gives the force of gravity between 2 different objects with masses capital M and small m. Sometimes that's m1 and m2. And then r is the distance between those two objects. G is the universal gravitation constant. All right, so we're going to find the mass of the moon, assuming that the big M is the mass of the Earth and little m is the mass of the moon. So we need to solve this for little m. So we've got this fraction with r squared in the denominator, and to get rid of the denominator, we multiply both sides by that. So we're going to multiply r squared on both sides. Now the r squareds cancel, so those are gone. So we got r squared f on the left and g m m on the right. And now just like we did before, we're just going to divide by the two variables that we don't want. All right, we want little m, so we'll divide by g big M. So that gives us m equals r squared f over gm. And now we can plug in. The distance between the two is 3.8 times 10 to the 8th. And that's going to be squared because r is squared, so we have to square that value. The force, 2.1 times 10 to the 20th newtons. And then universal gravitation constant, 6.67 times 10 to the negative 11th. And big M, mass of the Earth, 6.0 times 10 to the 24th. All right, so we're going to have to multiply using scientific notation. First, multiply straight across on top. 3.03 times 10 to the 37th. And multiplying across the bottom, we get 4.0 times 10 to the 14th. And we'll find we'll divide these two. And for the mass of the moon, we get 7.6 times 10 to the 22nd kilograms. So make sure you feel comfortable using scientific notation in your calculator. All right, that's it for today.